the run, but this is not that, true? So I think the units are going to be a little different, yeah? So, given your coefficient with your units, why do we think everybody's coefficient number is different? Okay, check your neighbor now. Why do you think everybody's coefficient number is different? Yes. Yes.
Yeah, I guess that makes sense. Then everybody's different. Except ours is really fast.
All right, what do you guys think?
The distances are different.
So, say it again so I understand it.
The distances are all different.
So, what do you mean by that, though?
Can I explain?
Yes, please.
So, when we had this, like the balance thing, and then the ball on the other side, everyone's ball was a different distance away from the middle. So that affects it.
Were all the balls the same?
No.
We don't know. You told us not to touch them, and then you came around and were sneaky and moved them.
I did move them, yes. So,
Such a difference.
But they're like, you weren't getting like exact, like you were like, you know, when like it was like kind of tipped, you're like, oh no, that's fine.
yeah,
So you kind of just picked the one that like was like best for your group. So
right, and that's okay, but because the best fit line is going to do that. But I think my question is, why are the coefficients different? But I think it's the same question. Like, everybody hold your boards up so we can see. Like, at 200 grams, Lauren, what was your distance?
39.9.
All right, so let's round that to 40. Okay? So if you take your mass times your distance, right? You have 200 times 40. What's 200 times 40?
8,000.
It's 8,000. And what's your coefficient? That's right, it's 8,000, right? So, well, let's do, what was your 200 distance?
11.5.
So what's 11.5 times 200? Well, what's 2 times 11.5?
23.
23, and then times 100.
2300.
And what's your coefficient?
Whoa.
It's 2,300.
Whoa.
Because didn't we just say that the coefficient was the mass times the distance?
Yeah.
What if you do 100? Your 100 mass times your 100 distance.
2300.
And what's your coefficient?
2300.
2,300.
No.
You guys with me on this?
Yeah.
So, how could you find the mass of your ball? Check your neighbor now. How could you find the mass of your ball?
Well, how far would the ball go?
That's, you would have to know the distance,
On the other
right?
side.
So, because it's balanced, the mass distance product of the ball should be the mass distance product of the ball.
Wait, wouldn't it just be 22?
So if you do the distance to your ball, you find the mass of your ball. The mass of your
Wouldn't
ball.
have to equal 2258, so that's where the other ball would be? On some variation of that.
All right, anyone want to take a wild guess as to how you could find out the mass of your ball?
You need to know how far away from the center it is.
That's exactly right. Right? And if you knew that, what would you do then?
Plug it in, and then multiply by 1 over whatever your coefficient is, and you get your answer.
Yeah, so I like that. So because you had to balance, 2,300 for you guys is your mass distance product for the ball, correct? So if your ball was, 10 centimeters away, what would the mass of your ball be?
Wait.
If your ball was just 10 centimeters away from the center,
10 here.
230? 230.
this is some good mathing right here.
Okay, so it would be like 230.
That's right, it would be 230 grams, that's right.
Hey, I got it.
Only if it's like
Nailed it.
5 units.
All right, so here's the deal. This information, this inverse variation, okay, is important for us moving forward because some of the times the laws that we develop in class, we're gonna need an inverse variation concept, right? You guys with me on that? So